So I brought the book up so we could use it. Is there any questions on anything that's due this week? No? Okay. There is the introduce yourself where you want to meet me sometime today, tomorrow, or Sunday. Um, I have an office hour after class, so you can link into my office hour. Um, but is there any questions? These are from 9.4, and I don't think I finished everything. I'm not sure. Okay. Let's just do a couple just to make sure. I don't remember doing, where'd my cursor go? These. Did we do any of these? Anyone? We'll do two. If you look at number 27, when there's only one fraction on each side and you're going to solve it, you can just cross multiply. So if we had 3x minus 2 over 7 equal to x plus 2 over 5. So one fraction on each side, you can cross multiply. And so then we're taking 5 times 3x minus 2 equal to 7 times x plus 2. It's one way of getting rid of the fractions. And then we can distribute the 5. 15x minus 10 equals, distribute the 7, 7x plus 14. So then you're using the steps just from the other ones we had done. Get the x's together by subtracting the 7x. And add the 10. Now, if you can do this part in your head, you do not have to write the plus 10 on both sides. And divide by 8. Any questions on that? I think I have one on a squared. 33. 30. Okay, we'll do 33. And these come right from your book. 1 over x minus 2 minus 3x over x minus 1 equals 2x plus 1 over x squared minus 3x plus 2. Now, when you have fractions and you're trying to solve, you could, excuse me, get the same denominator and then combine the top. But when you have an equal sign, if you multiply through by what would be the common denominator, it gets rid of all the fractions. But in order to do that, we'd have to factor this first. So we need two numbers. When we multiply, we get 2. That when we add, we get a -3. And a lot of times, if you look at your other denominators, it's probably one or both of them. The only thing that multiplies to get 2 is 1 and 2. When we multiply, we get 2. When we add these, we get 3. Well, we want a -3, so we could make both of them negative, so that when we multiply, we get the +2. And when we add, we get the -3. So it would be x minus 1, x minus 2. Any questions on that? Now you want to take one of everything. So we're taking an x minus 2 and an x minus 1. We don't need to repeat it. These both are also the same thing. So if we multiply each one, and you have to do that to each term, our denominators will cancel. So on the first one, the x minus 2's cancel. And then you can distribute the 1 here, or you can distribute it later. I think I'll write it out so that you can see what we're doing. Normally, I would just do my distribution there. But it would be 1, which doesn't change anything, times x minus 1. The second one, the x minus 1's cancel and leave a minus 3x, which remember that negative goes with it when you distribute, times x minus 2 equals 2x plus 1. And notice x minus 1 cancels and x minus 2. So on this side, we only have 2x plus 1. Any questions on that? Then distribute. Distributing the 1, we get x minus 1. Distributing the -3x, we get a -3x squared plus 6x equal to 2x plus 1. Combine like terms. -3x squared, 6x and 1x is 7x, minus 1 equal to the 2x plus 1. And when you have a squared, you need to get it set equal to 0. I'm going to subtract the 2x and subtract this 1 so that I have 0 on this side. I have a -3x squared plus 5x minus 2 equals 0. Any questions on that? No, this one, it is factorable, but since we didn't do the quadratic formula, I want to use this one on the quadratic formula because I know it was one of the ones I wrote down to do, was a quadratic. Because sometimes it's not factorable, and so then when it isn't, you need to use, and you'll want, if you don't already have it memorized, you do want to memorize it. The quadratic formula is x equals a -b plus or minus the square root b squared minus 4ac all over 2a. And that is when A is with the squared term, B is with the x term, and C is the constant, and it's set equal to 0. So if you don't have this memorized, you do need to memorize it. In this problem, then, A is a -3, B is 5, and C is -2. Now, the biggest mistake that happens is you take the variables with it. It's only the numerical value in front. So x equals a negative, b is 5, plus or minus the square root, 5 squared minus 4 times a times c, which was -2. All over 2 times a, which was a -3. -5 plus or minus the square root, 25 24 squared. 4 times 3 times 2 is 1. 25 minus 24 is 1 over the -6. So if you combine under the square root, you should get 1. Square root of 1 is 1. So it's 5 plus 1 over a -6. 5 minus 1, it's a -5. So you do the plus of the square root and then the minus. Now, if the square root, say it was 13, it's not a perfect square root, then this would be your final answer. But it's a perfect square root, so we have to look at the plus and the minus. -5 plus 1 is a -4 over a -6, which is a positive 2/3. Here we have -6 over -6, which is a positive 1. Now, these are two possible answers. I guess I shouldn't have circled them because they may not be. Any questions on getting them? We look at the beginning. You can't have 0 in the denominator. And 2/3, 2/3 minus 2, or 2/3 minus 1, that's not going to give us 0. And the same thing here since it's the same factors. So we're fine with the 2/3. But then the one answer was 1. 1 minus 2, that's fine, it's a -1, but 1 minus 1 gives us 0. So if you will get 0 in the denominator, you need to omit that value. So anytime you have variables in the denominator, you need to check your answers. When we get into the section, we will learn about domain. And so then we would find that first, because the domain are values you need to omit. In this case, if x is 2, I get 0 in the denominator, and if x is 1. So my domain would be x cannot equal 2 or 1. So then when I get that value, I would omit it. So if you have a fraction with a variable in the denominator, check your answers. Any questions on that? Okay. One other one that I wanted to do, like 15. 4x squared, I don't think I did it. 4x squared minus 36 equals 0. There's a couple ways you could solve it. One would be the quadratic formula. Another way of solving it, we could factor it. First, notice we can divide by 4. So when you have an equal sign and there's a number in front, if you can divide it out, it's nice because it makes your number smaller. So anytime you're solving and you have large numbers in your equation, if you can divide everything by a number evenly, then you can divide it out. Now we could factor, this is the difference of squares because it's x squared minus 3 squared, x minus 3, and x plus 3. And then, remember, once you factor, you set both of those equal to 0. And we get x equals 3 and x equals negative 3. So this would be solving by factoring. We can also solve by the square root method. To solve by the square root method, you get the squared part by itself, so we would add the 9 to the other side. And then you can take the square root of both sides. But when you take the square root of both sides, you need to remember that it will work for a positive and a negative. So if you're taking an even root, it leaves a positive and a negative answer. If it were an odd root, like a cube root, it's only whatever sign you have. So it wouldn't be positive and negative. But even ones, it's positive and negative. The square root of x squared is x. Square root of 9 is 3, so it's a plus or a minus 3, which is the same thing we got here. So all three methods would work. You could use the quadratic formula, factoring, or square root method. Any questions on that? Now you only use this when you don't have the x term. Any questions? We don't really cover review 6. It's just inequalities. I meant to say review 5 is inequalities. Review 6 we do cover. What you want to remember is when you are dividing with the same base, well, we did the division one, but then you subtract top minus bottom. When you multiply, you add them. If you have a negative exponent, you can move it to the denominator. And anything to the 0 power is 1. So these are, and once you start doing them, you won't have to memorize, you'll know them. So the first one we have 8 to the negative 2. Well, the negative moves it to the denominator. So if we move this to the bottom first, it makes it 8 squared. And then 8 squared is 64. And I think the attendance problem's similar to that one. I have that with me either. Yes, I don't. But I know it's something similar to this. Oh, I think it has a fraction though. Okay, let's try these ones. Number 4, negative 3/4 to the 0. Now, we know that anything to the 0 power is 1. This whole thing is to the 0 power. This would be 1. But if we had this, it would be a negative 1. Because the only thing to the 0 power is the 3/4. So you need to be careful. Another thing that could have happened if we had negative 3/4 to the 0. Only the 3 is to the 0. So this would be a negative 1/4. You need to be careful. Parentheses are important, and without them, the answers are different. Another one where there's a lot of mistakes. If we had a negative x squared, if we want to find f of 2, the only thing that's being squared is the x value, which in this case is a 2. This negative is not being squared. So it's 2 times 2, which is 4, and this makes it a negative 4. What I always do when I'm plugging in is I put parentheses around the number that I plugged in, and then I remember that this is 2 squared times the negative. So it's a negative 4. The same thing if we had f of negative 2. When we plug that in, if you don't put that parenthesis, this is saying to only square the 2, but you want to square the negative 2 because that's the x value. So negative 2 squared is 4, and this makes it negative. The biggest mistakes I see when I have this is these, because it's not that you don't understand the problem, it's just the way you're plugging it in. So every time you go to plug in, put parentheses and then remember your rules. Any questions on that? Try number 8. 4/3. All right, to the negative 3. Oops, I said 2, but I wrote. Now, when you have a fraction with the negative exponent saying move the 4 down and move the 3 up. If you wanted to rewrite it first, you could, because it's 4 to the negative 3 over 3 to the negative 3. Move the 3 up to make it 3 cubed, and you can plug or solve the value at the same time. But the negatives in an exponent just moves it up or down to make it positive. And then 3 cubed, 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. I think there's one more, yeah, the exponent rule. Is there any questions on that? One more rule you want to add in here. If you have an exponent to an exponent, you multiply them. So this would be x to the mn. So an exponent to an exponent is multiplied. Let's look at number 13 first. X to the fourth, x to the third, over x to the fifth. When you're multiplying, you add the exponents. When you're dividing, you subtract. And if you want to do it all at once, you could. These are being multiplied, so 4 plus 3. And then this one's in the denominator, so minus 5. Seven minus 2 minus 5 is 2, so x squared. Any questions on that? C cubed over 7d to the negative 2. All that to the negative 2. So an exponent to an exponent you multiply. Remember, when there's no exponent, like on the 7, it's a 1. So it would be c. 3 times a negative 2 is a negative 6. And it would be 7 to the negative 2. It's negative 2 times 1. And then d, negative 2 times negative 2 is a positive 4. Then I want to make my exponents that are negative positive. It is not in simplest form if you have a negative exponent. So we move the 7 up to make its exponent positive, and the c down. And d is already positive. And then 7 squared, 49. Any questions on that? Let's look at one of the, I know I put one like 21 on my math lab. Is there any questions so far?
You said that when you flip them, you only flip the negative exponents.
Right. This one was a negative, so I moved it down, and this one was a negative, so I moved it up. So anytime you move it up or down, it changes the sign on the exponent.
Okay, so you just don't have to flip the ones you don't want to.
Correct. As long as it's all multiplication and division. As soon as we put an addition in there, we can't do that.
Okay, thanks.
Mm-hmm. So on this one, if we want to, because this isn't multiplication, it's addition. First thing, rewrite each term. So a to the negative 1 is 1 over a. B to the negative 1 is 1 over b. Now we have problems similar to the last section that we did. We have to get a common denominator in order to add fractions. Any questions so far? Our common denominator, we take both a and b. Just like we took both quantities, you take both variables, whatever's in the denominator. So our common denominator would be ab. So the first one, we have an a, we need to multiply by b over b, which gives us 1b. The second one, we have the b, we need a. So we can multiply by a over a. 1 times a is a. And nothing will simplify. So our answer would be b plus a over ab. So we rewrote it first, and then we got a common denominator, and then nothing combined because they're not like terms. Any questions on that? One more formula. So I keep putting M there instead of X. Is a fractional exponent. So if we have M over N, you can rewrite it two ways. You can put X to the M inside, but that denominator, that's a root. So if it was a 2, it would be a square root. If it's a 3, it's a cubed root. Now the M can be on the inside or the outside. Most of the time, if you're simplifying, you'll want it on the outside so that this makes your number smaller, and then cubing or whatever your exponent is on the outside, it'll get bigger. Putting it in here first, if you had a 9 to the 5th power, I don't know that you'd want to do it in there. For instance, if we had 9 to the 5 halves, we could rewrite that as 9 to the 5th and then take the square root of it. Or we could take the square root of 9 first and then take it to the 5th power. I'm using square root because this is a 2. And when it's a square root, you don't have to show the 2. But the square root of 9 is 3. And then 3 to the 5th. I don't want to do that one in my head. 243. But you could take 9 to the 5th first in your calculator and then take the square root. You'll get the same answer. Any questions on that? So number 29. We have 32 to the 2/5. So that would be the 5th root of 32 squared. 32 is 2 to the 5th. So the 5th root of it is 2. And 2 squared is 4. Any questions on that? Number 30. negative 125 to the 2/3. No, it's not in parentheses, so that negative is not to the 2/3 power. That stays out. If it was in parentheses, then it would be used. But since it's not in parentheses, the negative cubed root of 125 squared. I would do the cubed root first. But since this is not in parentheses, that negative just gets carried along. The cubed root of 125 is 5 because 5 times 5 times 5 is 125. So this is 5 squared, which then is a negative 25. Any questions on that? $35. 27 over 64 to the negative 1/3. Go ahead and try that one. I didn't put these in there. The negative is going to move the 27 down and the 64 up. So it would be 64 over 27 would make that a positive. And then if you want to rewrite, you could rewrite it this way over both of them, or you can do them each separately. Either way. But I did the negative first. I moved the 27 down and the 64 up, which then made that positive. Cubed root 4 times 4 times 4 is 64. So that's 4. And 27 is 3 cubed. 4 cubed. Any questions on that? The last review is, well, some of it we've already done, the square root parts. But when you do have square roots, let's see, number. Let's do number 10. Is there any questions, though, on the last couple we did? Number 10. In order to add and subtract radicals, just like variables, they have to be exactly the same under the radical. So the way these are written, you can't combine any of them because they don't have the same number under the radical. 3 does not have a perfect square in it because it's just 3 times 1. But 12 does. 12 is 4 times 3. So we know the square root of 4 is 2. So if you can find a perfect square in your value, it can be brought out. So we can take the square root of 4 out. And the second one, or the last one, 25. 25 is a perfect square, and 25 times 3 is 75. So 75 has a perfect square in it. So this will stay 4 radical 3. The square root of 4 is 2. And 2 times a negative 5 is a negative 10 radical 3. So the square root of 4 is 2, and 2 times a negative 5 is a negative 10. Same thing here. Square root of 25 is 5, and 5 times 3 is 15 radical 3. Any questions on that? Look at, oh no, I'm at square root 16. Okay. When you're simplifying a radical with variables, you need to be able to divide by whatever the root is. So this is a square root. We need to be able to divide these by 2. So first looking at the number, and I always break it into 2 parts. One that will simplify and one that won't. 16 is a perfect square. So 16 times 10 gives me 160. 10 is only 2 times 5, so 10 will not simplify at all. So this part will, this part won't. 16 times 10 is 160. Now, r to the 7th, when you have a square root, you divide your exponent by 2. Because remember, the root is the fractional exponent. If we had a cubed root, we'd divide by 3. So I'm going to take one of the r's and leave it inside. If I pull one out, I have r to the 6th, which is divisible by 2, because this is a square root. Again, this one, the s is odd, so I'm going to pull one out and leave it there, and then I will have s to the 8th. T to the 12th is even, so I can take all of the t out, because I'm going to divide each of these by 2. Because the radical, this 2 here, is a fractional exponent. Square root of 16 is 4. And then we have r. 6 divided by 2 is 3. We have s. 8 divided by 2 is 4. T. 12 divided by 2 is 6. And then radical 10 r. Any questions on that? The other important part in this section is rationalizing the denominator. Rule of thumb, you should never leave a square root in the denominator. So if we look at 27, 5, oops, not 5. Oh yeah, it is 5 over the square root of 7. Just like you don't leave a negative in an exponent, you don't leave a radical in a denominator. So we need to simplify this. Well, to get rid of a radical with a square root, if we multiply it times itself, the square root of 7 times the square root of 7 is the square root of 49, which is 7. So When you multiply a square root times itself, it just eliminates the square root. So the square root of 7 times the square root of 7 is 7. But remember, when you have a fraction, whatever you do to the bottom, you have to do to the top. That way, it's not changing it. You're multiplying by 1. So in the bottom, the square root of 7 times the square root of 7 gave us 7. On top, we have 5 square root of 7. Any questions on that? We'll try one more. So we have, what's the next one? 28. 5 over the square root of 10. We can multiply by the square root of 10 over the square root of 10. So we have 5 square root of 10 over square root of 10 times square root of 10 is 10. Now notice 5 and 10 will reduce, but to start with, at least we got rid of the radical. And then we can divide by 5 on the top and bottom. And we have the square root of 10 over 2. Any questions on that? So that's when there's one radical or one term in the bottom. If you look at number 31, we have 3 over 1 minus the square root of 2. Well, we can't just multiply by square root of 2 over square root of 2 then, because 1 times the square root of 2 keeps the square root of 2 on the bottom. So when you have more than one term, remember when we talked about the conjugate, I kept saying it. Here's where you'd want to multiply by the conjugate, because then it eliminates the radical. So remember, the conjugate is the opposite middle sign. Leave the top factored. When you multiply by the conjugate, you only need to multiply the first two terms and the last two terms, because outside and inside cancel. So we'd have 1 times 1, which is 1. And then a negative times a positive is a negative. Radical 2 times radical 2 is 2. Which gives us 3 times 1 plus the square root of 2 over 1 minus negative 2 is a negative 1. Now, this wouldn't be wrong to leave it like this. Go ahead. Was there a question? And then 3 divided by negative 1 is a negative 3. But either one of these would be correct. If we did FOIL it, 1 times 1 is 1. Then we'd have the outside, which gives us a positive square root of 2. And the inside is a negative square root of 2. And then the last 2 is the negative 2. And these cancel. So that's how you would get it. So if it's a conjugate, you only need to multiply the first 2 and the last 2. Is there any questions on that?